Hello, today I'm gonna show you how to correctly configure a Nav3DAgentConfig instance and explain the meaning of all its parameters. Firstly, we should configure the scene environment. I will do it in the usual way. To initialize Nav3D systems, you have to create Nav3D initializer game object. It contains Nav3D initializer component, and we just leave the default parameters. For all game objects we want Nav3D consider like obstacles, we have to attach Nav3D obstacle component. There is no need to keep any colliders. So, and here we also leave the default settings. Now let's create the agent that will follow to some point in space. Now let's create a point that agent will follow. Here I have a simple script that allows us to order an agent to follow some point in space. There is nothing interesting except this logic. Here is subscribed to on Nav3D init event. It described at the beginning of the documentation, and then on the initialize method we should call move to the target point that we will attach the agent. Let's create component base Nav3DAgent component, and then we should attach our simple agent controller. And here we should attach follow point as a target for movement. Now let's move on to the main part. Let's create Nav3DAgentConfig instance. And here we see following parameters, parameter blocks. The first one is behavior, and it's responsible for a kind of navigation in space that agent will use when moving. Generally, there are two kind of navigation types in space. The first one is global, when we're using the global path that avoids all static obstacles. Naming statics, I mean the obstacles that have Nav3D obstacle component on it. The second one, navigation type, is local. It is the movement by straight direction using only local avoidance mechanism, and the most preferable and most convenient for any gameplay situations is combined one, when the agent following the global path in space and simultaneously it using local avoidance to avoid other agents and their obstacles that he come too close to. And the next one, fault, is contain just one parameter, its radius. It represents the size of the agent that perceived by Nav3D systems. All systems like local avoidance and their agent storage system. Let's attach our description to see how radius embraces our body, agent body. It is recommended to keep the radius, to set the radius to the value bigger than the visual content of the agent and all its visual parts. So let's increase it, like maybe like that. The next one fold out contains speed settings. The first one is a base speed, and the speed the agent will moving with, and the next one is maximum speed that agent can reach during local avoidance maneuvers performing. It is recommended to use speed multiplier mode. It means that the maximum speed will be derived from the speed by multiplying to the sum factor. Of course, you should set up the max speed greater than the base one. If you want, you can set max speed independently relative to the base one. You should click absolute value and type it here. But we leave the factor at base speed value as the maximum one. The next section is dedicated to the local avoidance settings, and there are only two options in it. The first one allows us to limit the number of agents that are taken into account when calculating local avoidance in each frame. So if we enable it, the local avoidance system for our agent will only take into account the number of nearby agents that we set in the field below, and by default it have 3 value. The next one setting is allows you to enable or disable taking into account static obstacles when performing local avoidance. In most cases this is not necessary, but in some scenes agents may collide obstacles while avoiding other agents while moving. In such cases it makes sense to leave this setting enabled. I will not explain the contents of the advanced steps. You can read about it in the documentation on the website or in the PDF document included in the asset. The next tab contains pathfinding settings. This tab is visible when the combined or global navigation type selected. The first setting is pathfinding timeout, and it determines the maximum allowable pathfinding time. If the pathfinding takes longer, it will be interrupted with an error. You can read more about possible errors during pathfinding in the documentation. The next setting determines whether the path should be smoothed during the search, and if so, you must specify how many segments will be per cell of the search graph. By default it have 3 value, and the higher the value, the smoother the path will be, but it is not recommended to increase this value unnecessarily, because the higher this factor, the longer the smoothing procedure will take. And now for the last setting. When following the goal, the agent may deviate greatly from the found path during local avoidance maneuvers. The agent may even have difficulty to returning to the trajectory of the found path, since nearby agents may force it to constantly avoid them, and thus it may dance in place for a long time instead of moving along the path. Enable this setting if you want the agent to find a new path to the target if it has gone too far from the current path. Below, set a minimum time interval after which it can try to find the path to the target again if the agent has moved away from the original trajectory again. It's given in the milliseconds. And in the motion section, you can configure the agent movement characteristics. The first one allows you to determine how close the agent must get to the target to complete the following. The second one allows you to set the maximum number of degrees that agent can turn in one fixed update tick. And the third one determines how smoothly the agent's rotation vector will change from one fixed update to the next fixed update tick. And the smaller the value you set, the smoother the turn will be. The acceptable range of values is from 0 to 1. In the velocity blending section, you can set the velocity vector blending factors. The final agent motion vector in each frame is the result of blending the global path following vector, the closest agent avoidance vector, and the closest obstacle avoidance vector. You can read more about this in documentation. In most cases, you won't need to change the settings. And the last section is for debugging. If you think that the agent is working somehow wrong, you can try to figure out what is happening inside by enabling this setting. Then in the play mode in the agent inspector, a corresponding button will appear to show the agent log window. Now let's check that everything works and the agent moves to the target point. Here we can highlight the current agent path from its primary position to the target that we ordered to follow to. And we can highlight agent velocities, current velocities, the meaning of the color of the vectors described in the documentation. And we also can highlight nearest agents and nearest triangles. But now there is no need to enable these settings. And yes, everything okay. The agent moving to the target point. Let's add another one agent that will do the same thing but in the opposite direction. Let's duplicate follow point. Both agents will have the same config. Attach our new following point in our controller. We have to move stuff in the opposite sides of the scene. And let's check that everything works correctly. Yes, quite good. But I want their paths to cross. Let's try to move the both follow point upper and look how it goes. Not the exactly I want, but a little closer. Yes, and here we can observe how the local avoidance works in action. And now let's disable local avoidance, leaving only global navigation. Let's move the agents a little bit to guarantee that their paths will cross. But they still not cross. Let's perform some more corrections. Yes, now it's right here. And we can see that they ignore each other and just moving to their targets without performing local avoidance maneuvers. That's all I wanted to say about setting up the config for agents. If you have any additional questions, visit the website, read the documentation, and you can contact us with an email. The link to the website and the contact email are in the description of the video. Thanks for watching.